Bienvenue and welcome to the Developer Digital Meetup Tour, where we'll be going across Canada to talk to incredible developers doing amazing things in their companies, their communities, and in their lives. So we're really looking forward to this opportunity to share, connect, and learn with all of you across Canada and brought directly to your homes. My name is Kim, and today we'll be talking about evolving an as-a-service solution. But before we get started, a couple quick housekeeping items. Firstly, if you have any questions during the session, I really encourage you to ask them as they come up. You can send them over by selecting the Q&A button on your screen and inputting those into the window. Our team will respond as soon as they can with the questions in real time today. And so, secondly, please note that a recording of today's amazing session will be sent to you via email within about 24 hours following the completion of this session today. And so please check your junk mail if you don't receive that message, as you might want to go back and watch this incredible session right down the road. And so finally, this webinar also has closed captioning, so you can turn that feature on in the bottom right corner of the media player. Bottom right? I think that's enough from me. Let's head over to Quebec. Oh wait, I'm already in Quebec to hear from these incredible speakers from Nmédia who will be sharing their experience evolving their silent auction app over the years and shifting between systems, so platform as a service, infrastructure as a service, functions as a service, you name it, and really find out the secrets behind their journey and the choices that they made along the way. So let's get ready. Everybody put on your virtual headset and I'll see you all in there. Ooh. Oh, are we not doing that? I thought VR was the future. Oh, well, maybe in 2020. It is 2020? Oh, well, good thing we have Microsoft Teams. Let me call them in.
Hey, hi guys.
Hi, Patrick.
How you doing, guys?
I'm doing great.
Doing good.
Cool. So welcome to this awesome event, evolving with an as-a-service solution, which is our place to showcase what we've built over the years with Follow My Bid, one of Nmedia's internal product that we are delivering in the market. We've been developing that platform for a couple of years now, and we've all written that up from scratch last year, and we've really developed a first-class solution built upon a cloud solution. So it's all cloud native APIs and different tricks that were put in place. And that's the reason why you are here today to watch us talk about what we've delivered and how it's implemented under the hood. So I think that will be the main purpose of our day, guys.
Yes.
Yes. Giving
Cool.
all our secrets and our thought process behind that solution.
Exactly. So as André Philippe said, we are here to answer all of your questions too. So please, you'll find somewhere around our stream the live chat. So please hit us with your question, and we are backstage. We can answer your questions in real time. And at the same time, at the end of the event, we will still be there to answer some of your questions. So if you have some wrap-up questions that you want to have later on, just please don't hesitate to stick around till the end and hit us with your best shot at that moment. We'll be there.
And
Yeah.
even if the video closed, we're still there. So
True. We had that experience in another webinar. So even though it seems to stop, please try to hit us with a question, and we might be there as well. So obviously, to put some perspective with this webinar, you'll see that even though we have this great French accent while talking English, you'll find that we are some lovely folks who can answer some of your questions and go deep dive into the technological field. So without any more time, let's hit our PowerPoint presentation here. So to give you a little time and place where the solution sits, we'll just go back to a little bit of history, who's Nmédia and how come that we are building this awesome platform known as Follow My Bid. Then we'll go and hit the management application performance theory, which will be led by my friends and the cloud solution that was built. So we'll showcase some of the questions that we had and how it was all done. Then we'll show you some little drawings. So for all of you guys, the architects in the crowd, you will be very satisfied. And we'll end up with this little Q&A time at the end. So have I forgot anything?
It's perfect.
That's it.
It's perfect? Cool. So if we start with our solution, what is Follow My Bid? It's a web auction tool. So it's a tool that can help a foundation to gather some money if they have an event and they want to put some product at the auction. We've developed a platform that can help them transform those products into money for the community. So by way of fundraising, we've transformed some computer cycles towards money for the community. And the way it all started is with an event that we did in 2012, which is for two old NHL players, Mr. Gervais and Mr. Talbot, who are both native from a small town here near Drummondville, where we are in Quebec, named Saint-Hyacinthe. And they both had this golf tournament where at the end of the day, you can see in the picture, everybody would gather for the lunch, and there will be a lot of product put at the auction, and all of the funds that are taken from that moment will be given to those charities. So they've asked us in 2012 to, hey, do you have any do you have any product that you could give to this auction? Do you want to participate? And we say, hey, wait a minute, instead of just having giving you money, we'll try to figure out, is there a way to get more money out of every pocket in that evening? So that was our first shop that we've tried, and the first architecture that we've built was really tailored for one specific evening. It was for that night and that night only. It was in order to try to do some SMS and to get the various participants involved more involved. So as you can see, the architecture was rather simple. We've had the administrator that could place the product inside inside of a web application, and all of the images and everything was stored in our locally in our own infrastructure where we've deployed a small web application. And after that, you have here it's still in French. That is miseur, so it's bidder. It's the name of the guy who's bidding on a product. So that guy would later on go to the website and see all of the products that were there on the auctions, choose a product, and then say, okay, for that jersey of Michael Jordan, I want to pay like $500, and he'll hit 500. Boom, it will be sent. Later on, if Gabriel sees the Michael Jordan jersey and says, hey, I want to have that product, he just goes and say, hey, $550 for me, hit the I bid button, and then boom, he's the current winner of the product. And I, who tried to have it at 500, will receive an SMS on my phone saying, hey, Patrick, you've been outbidded by your friend Gabriel, who's now leading that product auction at 550. What do you want to do? Do you want to raise or stay that way? So I can raise and boom. So you see the way that it works. So we've transformed the experience from being only paper and pen with the product showcased in front of it, that had some, and people would bid in the first 10-15 minutes, but it would stop there. So we've transformed that with the digital ecosystem, with the SMS and the web apps, so that all over the evening you'll still have activity and you'll get way more money out of your event. So that was the first iteration that we've did. It went really well. The people were engaged. So in 2014, we've decided to make it real. So it was a matter of, okay, now we've put some of the, as you can see in the picture, we had the folks from Nmédia who could take the various participants that would come in and register them so that the experience was easy and nice. Then we had a lot of other folks from Nmédia that were there to help in the evening, to help raise money and to go see every table and say, hey, do you want to raise, do you know how it works? Can I show you how it is done? So that was all part of the change management for that specific evening. And on that day in 2014, the architecture was, you have some other pictures of the events, how it works, and you can see that they've raised quite a lot, and they actually raised a lot more money that year than the year prior when they didn't have the Follow My Bid platform. So, and it was multiples of more money that they had. So it was a really, really great night for that. The architecture was kind of a rinse and repeat of the first solution though. So it was a matter of, we had the in 2012 we developed the platform. It was still holding, with rubber and duct tape, so it was still that kind of platform. It was for one shot only, so everything was hard coded. It wasn't that manageable. There wasn't a lot of monitoring, so we've took some time to pivot and bring that encapsulation inside of an infrastructure as a service solution. So we still had the same architecture, but for every event we can just spin the new VMs, and those new VMs would hold the database, would hold the images and the various content, so everybody could still enjoy for my bid. So with that version, we had a cost of approximately $200 to $400 per event for all of the resources inside of a VM or inside of one infrastructure as a service implemented solution. So it was a rather high cost of operation. We could sell the solution higher, so that was okay, or it was a way for us and Nmédia to give to the community by absorbing the cost, but it was still rather high. And the reason why it was rather high is the fact that we were in an infrastructure as a service. It wasn't like cloud native per se. It was using old days technologies in order to take it easier on us to develop the platform. But it was still a 200 to 400 because we had to put the platform in place like a month prior to the event so that the administrator could put in the various information like the products, who will give the products, the information about the evening and so forth. So it had to be put in place prior to the event, like a month before. And a couple of days after the event, it was still up so that people could hit the payment or could have their receipts and things like that. And we had to put it was like a 2-day effort to put it up and have the tear down at the end of the day. So it was half of too costly and half was it was hard for us as a scaling solution to have every time 2 days worth of work to be done. So
yeah,
what we
and you have the guy to pay the guy who's doing that also.
are we paying them? Yeah. Okay.
I think, yeah. Well, I get paid.
So I guess it worked. Yeah. Oh yeah, and I was actually like in the same stance as I was in the picture there. So in 2020, we've decided to make it real, and so here is what we will show to you. So for this third iteration, we are going to a new cloud solution, which is based with the various little key components of the cloud instead of having like those huge VMs that we are managing. So it's really tailored for the mediums. What you have there is our new iteration. It's our V3. It's out right now. So that was our first kickoff event that we did internally here at Nmédia in the good old days. I don't know if you remember those guys, pre-COVID days, where everybody were standing together, having lunch, sharing pizza, and raising money with our platform.
Yep, also naive.
Also naive and happy were we. So yep, so that was, as you can see, it was in the holidays. So we've took some product that we've bought, like liquors and things like that we knew would be selling well at Nmédia, and we've put them at the auction, and all of the funds were given to a charity here in Drummondville. And with that in mind, we did that kind of new architecture. It was with the various administrator that you can see. They all have their own little kind of little tenant or experience, or they have their own subscription. You have the misère, the bidders that have a one-on-one affinity with what auction they are currently playing. So everything was built inside of a web application, and you can see that all of those resources are used at maximum usage, but it was now made as a platform as a service and a function as a service solution. So it can scale horizontally really well with the demand. So as there is new auction or new event to manage, as there are new bidders that are coming inside of the platform, we are still using the same architecture, the same resources, and we are scaling horizontally all of those various resources. So if we want to share with you guys a lot of information, here is what's amazing. So for the that slide does say V2, but it is V3 actually. So those are the statistics for the V3 version. The cost went from 200, 400 to something close to $4 or $5 per event. And those costs are still going down right now, so that's still in the work. And we went from like 2 days to put the solution in place and take it down to approximately 0 hour at all. So it's all managed internally in the platform. It scales up, down easily. There's not a lot of manual thing to be done in that new platform. So that was a great achievement for us. It helps us to go way quicker to scale up as a business inside of that field. It helps us put more money inside of the pockets of the various events as well. So with that in mind, we will put a little pause right here, so that before we start the management application performance theory, we'll share the mic with our folks over at Microsoft. Here to you guys. Okay, so I think we are back on track now. Who's next?
Yeah,
on the
fast
Price
like
is
that.
Right?
I was next. I was wondering if
again, I think you are talking, but
Can't
I
hear
cannot,
you.
I cannot hear you.
At classic, my microphone was mute.
Oh, there you go. The joy of life. It's true.
Yeah. There were sounds upstairs, so that's why. Anyway, I was wondering if you will speak as fast as you do in French. Turns out yes, but still always relevant. So it's
Thanks.
okay. Before I go deep into the subject of performance theory, I will add some details about our domain. As you can imagine, the auction domain is kind of special when it comes to managing the loads, how people use the application. So it's relatively calm, and then during the last minutes and even the last seconds, you experience like a huge spike of activity. So we know that in the cloud you have auto scaling option on about every resources, but these options are great, but for that kind of domain, that kind of load that changed so fast, we couldn't use these options. So you go from zero, like few updates per hour to per minute to like multiple hundred of actions. Yeah,
exactly. You can go from like 0 in the last 15 minutes, in the worst case, to like thousands in the last minutes in the worst case. Yeah.
And sometimes the auction are open for more than a week. Like it's not always a one night thing. So you will have a slow traffic during all the week, and at the end everything happened. And as Patrick explained, we plan to run a lot of auction at the same time. So and auction don't end on a Monday night or a Tuesday night. They will all end on Friday night and Saturday night. So about I'm looking for my words.
Yep.
Anyway, they will all end at the same time.
Exactly.
And,
So it will be hard on a Friday nights because it's always like it's 10 p.m. and everything will end at the same time. So if you're scaling horizontally, you still have to manage that. You'll have high peak there. So if you're going like 1,000 bid per minute with one auction, and you have like a couple of them at the same time. So if you have 100 of them, you multiply them because they are all sharing the same pool of resources there. So if you want to share, if you want to scale horizontally really fast, really good, then you need to perform some benchmark analysis beforehand. And yeah, those are the things that we did at Nmédia. And I think you're right. I think I do speak a little bit too fast in English too.
But it's okay. It's okay. We understand you. Well, yeah. And I went to two auctions actually, and there was about like more than 200 items for more than 600 people.
Mm-hmm.
So that was a lot of loads for one single event.
Correct.
Okay, and now I will explain some things about performance method because it was our challenge here with trying to get the cost low. We can just buy the biggest server and expect it to well,
To
because
deliver.
no, it will deliver, but it will be useless like 99% of the time, and then we will use it like for 1%. So at first, so why we didn't go for a simple like application with a normal front end with a single web server? In theory, a web server that is relatively powerful, 2-core, 3-core, you will be able to handle hundreds and thousands of requests per minute and hour. So before going crazy with by introducing a lot of technologies, I had to justify why it's not just a web server. And to that question, like, why do we as the industry develop management applications that are slow? What happened that management, if we're not doing complex algorithms like video games or image process
Processing.
and things like that, why the application become slow? You have the slide right there. The management application are really data centric. You want to see a lot of things while a lot of things is happening, and the more at the beginning the application will start really simple, and at the end you will realize that you will have maybe 100 of kind of data everywhere in your screen. So that's how it all start to generate that kind of data contingents. But I know there are other cases of why an application can be slow, but over my experience with management application, again, that's what I experienced the most, that I saw the most. Because it always starts really simple. You have one use case, you want to display one item, you type your request, you use a SQL server, and it's pretty fast. And then after 2-3 years, things start to go dramatically that word.
Slower, yeah.
Yeah. And then the system is big, so refactoring everything costs a lot, and it's difficult to judge what you do first. So if you do things right first, then it will go much more smoothly after that. I will give a few solution after that. But first, let's talk more about data contingency. Yeah, you can go to the next slide, Patrick. So what caused that contingency in those locks? It's by reading big data sets. So are you just displaying one item, or are you trying to get all the items along with the user's information, along with many other things? Also, long processes and long transactions. Long processes, you can imagine just a use case that you are trying to do a lot of things. Like if I'm bidding on an item, if I try to send an email during that and things like that, it counts as a long process. And long transactions. Long transactions are less and less true nowadays, but they happen on transactional systems that still use SQL servers and things like that. But with all the new SQL environment nowadays, operations are supposed to be what's the word? Atomic. Yeah. But still, you can go to the next slide.
And if I might add, what we see most of the time with the long transactions is that you have it starts with a short transactions where you do a simple operation, and then through the sprints, some features add up, and everyone has is simple step in the transaction. It's a little step. We can do that in the transaction and make sure that the data is in the transaction, but at some point it becomes a huge transaction, and now the system becomes slow and you get some deadlocks.
Correct. What we would like to have in the industry was something like reversing the entropy of the system, so that we can go back in time with the various point in the solution and just put that entropy out from where it started. And so you need to stop time at that moment and start refactoring and having all of those conversation with managers and clients and expectations. So yeah, you're correct. Good point.
And that's the more obvious. Maybe I didn't explain reading big data enough, but I had an example with that. Like try to imagine like you're going to a library and you tell the person, "Can I rent all your books?" The person will be, "You're crazy," but but well, you can't. Some books are out there, so okay. But can you tell me when they all will be there? They can go forever. One comes back, one goes out, so you will never be able to have all the books at the same time. So that's this kind of data read that we try to avoid. Nowadays, with the new framework composed with component, it's less and less complicated to do that because you try to build a small component that have only a smaller data set. But I will explain that later. After that, something that is obvious again, but we still do as the industry. We still do in the industry is going with long processes that using external resources like sending emails, CRM communications. I said sometimes fast, sometimes not, because well, when you develop, it's always fast. You develop on your desktop and it was fast, and then you deploy it, and one day the SMTP server or SendGrid or anything like that is slow, and the entire application start to become slow because you were sending emails everywhere. Sometimes we know that, but building asynchronous processes is not always that simple if you start from scratch, if you don't have any job systems and message queuing, etc. Because when you have a web server, you will work inside the HTTP context. The app may recycles, things like that. So it's not always that obvious to build an asynchronous process. After that, I have some cue to give to avoid this problem. So the first one is fragment data models used to display. Talk a little bit about that. Nowadays, when you build small components and you go only take one small part of the data, you will avoid this kind of problem. Like the example I gave with the library, if you go for one book, chances are they will have the book, or they will tell you when the book is back, and it's going to be pretty fast. After that is build aggregates that answer to a maximum of use case while keeping them as small as possible, which means that if you go to with a relational model like SQL and you develop your model like naively, is that the word, naively?
I believe so.
Yeah, okay, yeah.
It's naive.
Yeah,
Naive.
you will build more and more relation, and you will have to pull a lot of strings to get your data together. Instead, what you can do is still in a relation model, but it's easier with technology with no SQL, but you still can do that. You will try to build aggregates that answer to a maximum of use case. What's an aggregate? These are objects that often use together to answer to a use case. For example, an item may have the biggest bigger on it, but won't have the information about the invoices. You will try to separate that into a different aggregate, and it can cause some things that can be a little bit more complicated, because sometimes you will be forced to duplicate the data into two aggregates. But generally speaking, that's a good trade-off to do if you want to keep your system fast and also really simple to understand when you look at the objects.
And that's a challenge that we have when we're using, say, MongoDB, is you want to add some data, and then it doesn't fit in where you are, and you'd like to build some relations, because we're always using SQL. So it forces you to rethink your aggregates and how you store them, and what data you should be replicating and duplicating in other aggregates. But at the end of the day, it builds way faster systems, because you're forced to think about that right off the bat, instead of when it's in production and it's becoming slow over the time.
Yes, exactly. And it's always hard when you have a relation database background when it goes, because that kind of SQL database are really, really simple at the beginning. And having to think about your model is not necessarily the things you want to do at the beginning. You're like, I just want to build an MVP. It's a simple use case. Like, I don't have to think about these things. But well, it's always a trade of games. After that, accept that a process can be done asynchronously. That's what I said earlier with the email. I said it's not that easy to build a system when you have this done later. Also, it's kind of like, you don't have to do everything in a single transaction. What you can do is accept that eventually your system is gonna be
internally coherent.
Exactly. Like, everything is easier when it's inside a transaction, because you control, if something fails, everything fails, and that way you're sure that everything is always okay. But there's a trade-off there, that if you do that, sometime your transactions will start to become longer and longer. Like, instead, what you could do is build multiple smaller transactions to do maybe one use case that is complicated, but it has a trade-off that it become a little bit more complicated. But with the right tools that we have nowadays, with to log everything, the game become more about logging, understanding what's happening in your system, and once you do that, you can accept more easily that things are done asynchronously, and you can react and correct things if something happens. So yeah, it's a trade-off. It's more complicated, but you have to do that at one time at the project. Another solution is to maintain a sync-in database that is optimized for read operation. You can think with cache, like Redis use and Elasticsearch. The goal with that is, first, these tools are optimized for to build great indexes and read pretty fast. But as well is when you have people doing operation in your system, you can be more intelligent about how you update your data. That is the purpose is just for reading. So that way you can act in your system and not block people that are using it. That's one great way to do it.
Yeah, and you can model your database for writing, so how you're managing the information, but you can model your information to how are you reading it. Is that for BI? Is that for a screen with a lot of stats, or whatever, a search?
Yeah, that's pretty good. Yeah, that way when you model your aggregates can be really about the use cases, instead of all the smaller use cases that are all read operation that can be done by something else. And now I talk about all these practices that are good practices. If you apply them with a single server, you can still build a system that is pretty fast. So like, that was always the case. You can build a system that is fast with a single server. What changed the games is how simple it is to use more complex distributed system easily in your application now. So, for example, with the Phil will talk about that. Well, I will let you, Phil, talk about instead of going on your subject. I will let you talk about the solution, but I just want to tell everything with the cloud now. You do things.
Feel free to add up on the next section too.
Yeah. So
go ahead. I'll talk later about that.
Yeah, don't worry, Gab. So it's the time again.
Did it make sense? Did it make sense?
Yeah, it did make sense. And I was looking at where you were aiming, and I wasn't sure if I needed to change the slide or not, if you wanted to continue on that train of thought, or if you wanted to switch to André-Philippe.
Yeah.
This is it. So André-Philippe will continue right after we have more information from our lovely folks over at Microsoft. Okay, so Mr. Racine, I think it's on you now.
Yeah, so on this section, I'll speak about what solution we've put in place using Azure, so in the cloud. As we said, and as the title of the presentation says, we went with a function as a service mindset, going with the solution, so a cloud first mindset. So yeah, let's dive in. So first thing we did is to check on what were the solutions that were available for us to go with a cloud first solution. We first looked into AKS, so Kubernetes over at Azure. It's a simplified way to manage a Kubernetes cluster. It's a few clicks and you get your cluster with a few nodes, and everything is set in place, which is a lot easier than trying to set it up yourself. Kubernetes is a great tool to orchestrate your microservices and to manage redundancy and make sure you have high availability. Though we've noticed over a few projects that it's really a steep learning curve. So if your team is not familiar with it, the first steps are going to be hard and painful. Yeah, there's a lot of complexity to Kubernetes. You have to understand all the Docker lifecycle and a lot of command lines, a lot of YAML files. Yep, and it's also a high maintenance cost. The Kubernetes project is the open source project that evolves the fastest right now, and it's updated regularly on Azure, and you have to make sure that you upgrade your cluster as you do that. So it's a complicated process. You have to turn down some nodes and spawning some other nodes while it's upgrading. It's a complicated dance. So yeah, that's something to keep in mind. You have to have a team that's familiar with it to be comfortable running in prod with it.
That's so true, and we, as you've said, there's a lot of projects where we do use AKS or Azure Kubernetes services, and it's going really well. But the step to get towards Kubernetes is something. So if you don't need that dependency in your project and you can go without while using like function as a service or other various construct, then you might consider those which aren't maybe as popular as Kubernetes right now, but at the end of the day, which are way more simplified version to get your solution running than to build a Kubernetes stack and to maintain it, which is true that it is some challenge there. There are a lot.
Yeah. The next thing we've looked into is the Azure functions. We've already had some experience with it with the team that was working on the Follow My Bid. It's very simple to set up, and you basically have no maintenance to keep it up. It's it's a managed service, so Azure is keeping it up to date, and it's a serverless experience, so you don't have any VMs behind it to maintain, and the running cost is also pretty low. We're talking a few cents per million execution for an application like Follow My Bid. where most of the calls are driven by a human clicking on an interface. A million calls is not something that happens every day. So it was really cost efficient for us, and it felt like a good fit for Follow My Bid. So for those who are not really familiar with serverless, the goal of serverless is to abstract all the VMs and the operating systems behind your application. So what you want to focus on is running your code in the cloud and make sure it works. So you don't want to manage the updates, manage the disks, the backup, and all that. So it all becomes managed by the cloud provider, and you're just hosting some code. So with the Azure function, what you're hosting is basically a C# function in our case, but it can also be some other languages like JavaScript. And so the function is works with a trigger. So you have a trigger. It can be a cron, it can be an HTTP request, a message in a service bus, and you have a lot of connectors for the triggers. And it starts your function, which runs, and it returns a result. So the result, it's the output. So you have the trigger, the input, and the output. The output can be an HTTP response, can be something you put in storage table, can be a message in a new service bus. So you have multiple options there too. You have a few choices when it comes to the Azure function. You have consumption mode. So basically, the function will run, and if there's a lot of calls on it and it starts to slow down, it can spawn horizontally, and you will pay per million execution. There's also the premium version, which gives you a few features like connection to VNet and no cold starts and stuff like that. And you have the app service plan mode. So if you already have an app service with a service plan, you can join them. So basically, you're running your Azure functions in a VM that's already in the cloud. So you have less space for scaling horizontally because you're really in a VM, but you're not paying extra cost if you're already paying for that VM and it's enough for you.
Cool.
Yeah, so like I said, the price based on usage is very low. The first million executions are free, and then it scales for a few cents per million execution. There's also a price based on the execution time. So the how many CPUs vCore, I believe, is used for the execution. And like I said, you can also just put it in an app service and then you pay for the app service. So what we've done is we didn't have to put all the functionalities or the features in the Azure function. So we focused on what were the functionalities that required the most performance. And what comes to mind first is for sure the bid management. So like you guys said, we always have at the end of an event, like the 5 last minutes, people are outbidding each other. They're receiving notifications. They want to outbid on the last second and make sure that they get what they want. It's also the time that we can't lose the ball. If there's a lag and the people can get what they want, it's really frustrating. So it's really the features that we have to deliver on. So we went with Azure Functions for these features. We tried to keep an event-driven set of mind for this, and we also used to store those events. We used storage queues. Storage queues are a very low-cost option to set up kind of a service bus approach. We could also have used a service bus, but for this case, the storage queues were doing pretty much what we needed for a lower cost, so we went with it. So here's an example. Like we said, we're very transparent in giving all our secret. So here's an example of an Azure function that's handling the highest bid event in the follow my bid. So as you can see at the top in the parameters, you have a queue trigger in that case. So it's related to the storage queues that we were talking about. The outputs are the two singular hubs. So the function will output in the singular when the job is done, to make sure that we notify the different users in the application so that they see everything related to the outbid. So for the execution, it's a standard C# method. So we see the bootstrapper because we're going with the dependency injections, and then we're getting the containers there. We're deserializing the message. You see the isWakeUp event. So as I said before, with the premium functions, there's a cold start for the Azure function. So if the Azure function was not called for some time, it will shut down. And the first call needs to kind of hydrate that function, so you have a slower uptime. And to avoid that, you can run, say, some messages just to keep it up and running. And as the execution for these messages doesn't cost much, it's a good way to keep them up. So let's say users connecting to the application, you can send a few messages to make sure everything is up and ready for the calls. And yeah, that's it. After that, we're executing the use case and handling it.
So we'll wrap all of that together with Gabriel with his awesome drawing. But beforehand, hey Microsoft, here's to you. Hey, welcome back, everybody. So now it's that awesome moment where you'll have Mr. Gabriel Blebourget, who will showcase his drawing skills to explain and summarize everything that was presented today. Mr. Bourget, it's on you.
So I will try to make sense with everything we said earlier and what we did on the field with all those technologies. Okay.
Cool.
So I go. Look. So what we have first, we have our client, which is our browser, okay? And we kept the web server because it still has a small cost to manage the things like we did to get the maximum of performance. So all the administration use cases that didn't need that, we kept this as simple as we could. So we kept that. So we have a web server.
Yeah, that web server is leveraging what
in fact, it is an app service.
It's an cool.
It's an app service in Azure. But it doesn't have to be powerful, even if you're running a lot of auction, because as I said, it's only for the administrative use cases.
Cool.
And beside that, what we've built an auction engine. An auction engine. So the way it works is when you're doing a bid, okay, we first build an Azure function that is an HTTP trigger, that its role is only to to save a bid event. And that's the only operation we do. So you can't have more atomic than that. Nothing can happen that make the process slower. And one of the advantages, if it's that node that is slow, we still can work on this node only to give more resources for that use case. So instead of having resources for your entire system, you have resources you can manage per use case.
So that's one of the example in real life of the theory when we are talking about scaling horizontally. It's this powerful tool that you have right there that you can just spawn new nodes with the need. Am I correct?
Exactly.
Cool.
Exactly. And the operation is super atomic. Nothing can happen. So when I said a web server can handle 1,000 requests, that's that kind of request that you can do 1,000 times easily.
Okay.
After that, what we do, we throw that into a queue. So you have a bid event queue. Which is in the storage account. In the storage account, you can build, you can activate the queues in the storage account, and it costs what the storage account costs, which is almost nothing. So you have a message queuing system for almost free. But it's a simpler version than what you find in services buses and RabbitMQ, things like that. And what we have after that is we have another function that consumes that queue. And what it does, it classifies the bid. So using our BD is MongoDB. And as we said, MongoDB, all operations are atomic. And we use that atomicity to make our decision to who did the bid first. So when this function triggers, and let's say you have two bids almost at the same time, one will win the race, so it will get the operation first in the database. So you will go to the highest bid queue, and the other that lost will go in the outbid queue. And again, as you can see, all operations are still really atomic. Okay? Again, you could add more resources to this node only. What we do after that is we still have other functions that consume those queues. And what we did, we have the word plug in my head.
You've put in place?
Yeah. We've put in place a singular services. That his role is to push the result to our client. So you can see one of the complexity we have there, which is when you do an HTTP request here, what you receive a 200, okay. But that doesn't mean the operation still went well. That doesn't mean the operation ended. You will only know when everything's go and come back to your UI.
That's your eventually consistent aspect, right?
Yeah, exactly. So what we did, to supervise that system was really simple. We just worked with a correlation ID. So with the first event, we put a correlation ID in it, and we use that same ID across all our events. It triggers the other. So when we go in App Insight, we just have to inspect one ID, and you get all the use cases, everything that triggers for that use case.
Cool.
It was fast. Do you still do I have to explain more things? I think it's kind of complete like that. That's what we did for the auction engine. Everything is a different node that is really, really atomic. So if an operation is atomic, it means you can run thousands of them and it won't slow down your system because you are only blocking one resources at the time that go pretty fast. So your read operation is also a read atomic that goes right after what you did first.
Yep.
And the round trip is pretty fast. We test that using Gmeter, which is a tool for load testing, and we try to use like 5,000 bids in 1 minute. And using the consumption plan Andre Philippe explained, which is almost free for us. It is free for us. We could handle that kind of load really easy. So we have a really performing system that for $0.
Exactly. So
And is the round trip fast because you have all these Azure functions like vertically that are triggered? Is it still going fast?
Yeah, it is. That's what we were measuring when we built the test in Gmeter, because that one of the challenge. Sorry, I'm spoiling one of your part later, but one of our challenge when we were testing if this system support what we said it will support is it was hard to like when you do the first HTTP request in a tool with like Gmeter, you will get the answer and just do your assertion with this response. But because the response comes much more later,
yeah, it's
Yeah,
a matter of having
you-
your correlation ID put back in place together, because you would write your Gmeter scripts as something like, I'm sending this HTTP request. Do I have the answer? And then when you have the answer, it's like, okay, confirmation. It's okay. I've passed the test, or I have received an error code, an HTTP error code, and then you can define that request was failed. But for every call that we did, it was always 200, and you need to have like this that eventually consistency is really neat in order to scale. But when you want to test it against tools like Gmeters and things like that, you need to have another way to listen. Do I still have at the end of the day the signal R request coming in saying, hey, okay, everything is still consistent, every one of those operations performed correctly, and we did receive the okay, everything is fine, and you are the highest bidder, or you've been outbidded as expected per the test. So trying to do some testing of where will we break the system instead in the case of load testing was pretty hard, and it took us more time that we eventually take because it scaled really well, and trying to break it was really hard for us, and trying to have all of those signals saying, hey, I've sent the message, did you are you now consistent, do you have define who's the highest, and have you confirmed with them that they are the highest, and have you confirmed with all of the outbidded that they have been outbidded. Yeah, that was quite a challenge. Do I summarize that correctly?
it was perfect. That was what I was trying to say.
Yeah.
But during this time, we were also learning how Gmeter worked, because when you're listening to a signaler, you have to open a socket. It's obvious. It's easy using JavaScript and things like that. In Gmeter, it was a bit harder. And as you said, it was hard to make the correlation between what we sent and what we received.
Yeah.
But we did it at the end. We at the beginning we thought that the system was slow, but what we saw it's the Gmeter GUI that was slow. Using Gmeter as a command line unlock everything, and we saw that it support the cases we built.
Exactly, and those are the kind of things that we are really happy to share with you guys. And as we said, please hit us with the questions in the live chat, or we'll be still there at the end, which is coming really fast for us. And at the same time, if you want to reach out over at Nmédia, you have our names there. Just send us an email, send us a call, and we'll be more than happy to help you guys understand the various points where it might have been harder to showcase how it is done inside of the system. Anything else, Gabriel, on those drawing?
No. If you understand, I did my job.
Cool, that is cool. So if we are going back a little bit here, as I've said, is there any question? Or maybe we could ask André-Philippe, do you have anything to summarize before?
Yeah, so, well, that's pretty much what we've done to build our cloud-first solution. Of course, we had a few hiccups along the way. There are some complexities in doing that, managing security around managing security with the Azure function. We had some trouble with the assembly version. So to provide a simple environment for the functions to run, the most functions come with a few assemblies provided by Azure. But if you're using dependencies that are using other versions of these assemblies, you can have problems. And these problems are very hard to tackle because they're not always happening. So yeah, you have a call over each 10,000 call that fails with a missing method exception in one of your dependencies. So yeah, it was a hard one to find. And like we said with the performance testing, trying to correlate the information in the socket with the initial request was a challenge in itself. But these are all challenges that we've managed to tackle, and now we're pretty proud with the solution we've built.
Cool. Anything else?
That's it for me.
Cool. So I think we are all set now to receive all of your questions. If you have bundled all of those in one place, please hit us with them. We are more than happy to help you understand how we've developed that first that solution as a service solution built with cloud native, a cloud first approach. So we are answering in the chat, and we'll be still there in for a couple of minutes. So hey, don't hesitate. And Gabriel, André-Philippe, it was a real pleasure to share that experience with you guys.
Everybody, I'm still here. I just wanted to take a quick few seconds to talk to you all about the Microsoft Learnathon that we have going on right now. And so the Microsoft Learnathon is happening from September 1st all the way until December 22nd. And so you have plenty of time. And what it is, it's learning on Microsoft Learn platform, which is our free hands-on self-paced digital learning platform. And we've created 7 different challenges our team here at Microsoft Canada put together. So we hand-selected different modules and learning paths from the Microsoft platform that best fit into these different challenges. And so you'll go through, you'll learn, you'll complete the challenge, and at the end you'll have a chance to win a lovely Surface Book 3. So if you head over to aka.ms/learnathon, you'll see the 7 different challenges to choose from. So you select one, you'll sign up, and you'll get the collection that has the different modules and learning paths. And so you'll go through, you'll learn on the platform, and you'll be put into the leaderboard with your peers across Canada. And so you'll see how you're doing compared to your peers. So it's a nice little fun and friendly competition. You'll see how much time is left until the deadline, which is December 22nd. And on January 15th, we'll select the winners of the Surface Book 3s. And so again, that's if you head over to ak.ms/learnathon is where you can find out all those details. And just one more thing is thank you again for tuning in with us today. I just wanted to share quickly the other meetups that are happening with us. And so the next one happening is the Impact with Open Source. And so we'll meet with various different folks across Canada who are working in open source in their jobs or in their community, and we'll get to hear from them. And so there's other meetups happening as well, but that's the next one coming up. So don't forget to go head over to ak.ms/ddmt where you'll see all the other meetups happening for you. And if you miss any, you can always go back and watch the recording. And so those 2 links that I gave you today, ak.ms/learnathon or ak.ms/ddmt, and I think I will leave it at that. And so thank you all for tuning in today. Don't forget, any questions, use the Q&A button, and we hope to hear from you soon. So bye. Au revoir.
Yeah, it was fun.
Thank you.
Thanks everybody.
Thanks.
Bye.